In this video, we're going to discuss function notation and linear functions and how those go together. So we're going to start at the very beginning here with our definition of function notation. And function notation is used to give an equation that describes a unique output that we can calculate for every input. The way we want to think of this more directly is in this box right here. If you are taking notes, I would highly recommend that you write this box and the definition down for yourself, which we're going to fill in some blank spots here. A good chunk of this video is also going to be us filling some things in and things like that, so feel free to pause this video at any time and write that stuff in for yourself, underline it, highlight it as necessary. So the notation that's written this way, f parentheses x, is referred to as function notation. We read this as f of x. Write that in here. So this is not f times or anything like that. This is described as f of x. Or another way of thinking on this is f of x is the output value for an input value of x. And this is generally where some of the headaches and I think misunderstandings understandably start to come up here. Well, how do I know if I have an input value or an output value? Is the number, the variable, an input or an output? There's lots of room for confusion with that. So what I have off to the side here, I'm going to scroll this over, is a quick example of what we are talking about with input and output values and some things that we've seen up till now. So, by and large, when we are working with an ordered pair, we have an input value listed at the front, the comma, and then an output value listed at the end. Up till now, we've used x and y quite a bit to describe input and output values, and that still holds true for these variables with how they're set up. However, when we start to use function notation more, we're not going to have y showing up in there. The output value is now going to be listed as f of x. It is this entire thing that is the output value. So if we see some numbers written in, maybe I have an input value of 7, for instance, well, the output value is going to be f of 7. It's whatever this whole function, whatever that equation is, with 7 plugged into it, produces. So I just want to give this as a quick overview of how does input, output, x and y, and some of these numbers stack up to one another. So this is very much worth writing down and making a note of and referencing as necessary to make sure we're used to, here's my input and here's my output value. Because having that nailed down is something that's very, very important for the rest of this section and topic that we're covering. So as we're looking at this, we have a lot of different ways and some different forms that we can see function notation written in. Sometimes we're going to see it just as f of x, but we can see it written as g of x or h of t or maybe a of b, things like that. So this is another instance where we want to be very careful in how we interpret and work with the variables and values. Which variable represents the input values and which variable represents the output values. It's a very subtle thing, but it is very important as we are going through these problems. A couple warnings that I will also give, and again, I would recommend writing this down, making some red stars if necessary by this in your notes. If we see something written out like this, we do not read this as f multiplying by x or f times x. Similarly, if we have a number written in right here, we do not read this as f times 3 or multiplied by 3. This is f of 3. Okay? Now the last part I want to get to before we dive into some actual examples here is a little trick that I heard from a student a few years back, which I think is a very handy way of ever trying to remember, is the number I've been given an input value or an output value. Going back over to our ways we had here. So here's a way of thinking on it. The input value is always inside of parentheses. So input value being x in this instance. Where is x in function notation? It's in the parentheses. It's in the parentheses. So that could be something that you could use to help distinguish, okay, here's my input value. The output values, which we'll see more examples of later on in this video and on future pages, output values are always outside of parentheses. So we would see something like f of x equals a number, f of 7 equals a number. That number that we would have in those instances, that would be the output value because it's outside of this set of parentheses here with function notation. So just something to keep in mind as we're going through these examples here. Now with the examples we're about to see, I am going to go through these a little bit quickly because we're going to see that the process is extremely repetitive once we get the idea of inputs and output values down. So for our first example, we've been given the equation f of x equals negative 4x plus 3, and we're told to evaluate that for each of the following: f of negative 2, f of 0, and f of 7. We want to take a pause here and note, are these things, these numbers here, are they input values or are they output values? And because they are inside of parentheses, these are all going to be input values, which means anywhere in this equation that I have an input value, which is x, I'm going to replace it with these numbers and then solve each of them for whatever the corresponding output is going to be. So I'm going to write those in the space below here really quick. So here we have output values of 11, 3, and negative 25 respectively based on the respective input values that we would have. So all we just to do is determine what's the input value, plug that thing in, and just find the corresponding output value like we've done previously. Nothing really special or different about that. It's just a different way of writing these things. Now in the space below here with our second example, we've been given the function f of x equals 3x minus 4. We're told to complete the table that's given to us here and then graph this thing based on the table. Now, each of these things, negative 2, negative 1, 0, 1, and 2, are they input values or are they output values? These are going to be input values. They correspond with x. X is inside of parentheses in function notation, which means this is really just 5 instances of the problems that we just did above here. So all we would do is write in 3 parenthesis negative 2 or negative 1 or 0 or 1 or 2 minus 4 and then solve each of those out. If you'd like to do that, or pause the video and do that for yourself here really quick, go for it. I'm going to list in the answers here and then graph this, otherwise this video could become significantly longer than I would like it to be. But as we go through each of these, we're going to end up getting an answer of negative 10, negative 7, negative 4, negative 1, and 2, respectively. So now that I have 5 points here, 5 ordered pairs, how do we graph with ordered pairs? Well, we need 2 points. It does not matter which 2 we choose, but we need to choose 2, plot those, and connect them together. I'm going to use 0, negative 4, and 1, negative 1, just because I feel like it. They seem like they're reasonably nice numbers, and why not use them? So over here on my graph, I'm plotting 0, negative 4, so I'm counting down 1, 2, 3, 4, so I end it right there. My next point is going to be at 1, negative 1, so I should be right there. Bring out the ruler and see how close I can get this thing graphing. Try and get it reasonably close. That should do it. Ooh, no, that's way off. What am I saying? There we go. Maybe it'll... There, it's let me go again. Alright, that's better. Not perfect, but it will do what we're looking for. And if you're in my class, I'm willing to be a little bit flexible with this. So this is everything that we have with our first page and kind of the introductory parts to the function notation material and how we work with that. Let's go ahead and move on to our second page now. Looking at our next page, we're now going to move into some examples where we aren't going to be given explicit equations, but we can still answer questions about input and output values with function notation. So number 3 is telling us to use the graph shown below to complete the table. So we're referencing the graph that's right down here. Now we are told x is -2, x is 0, x is 2, and x is 4. Are these all input values or output values? Well, looking at function notation, x is inside of the set of parentheses, which means all of these numbers would be input values. So what we can do is look at our graph and say, where are these -2, 0, 2, and 4 on the x-axis, and where are they then on this graph? So I'm going to use a couple different colors here just to denote each of these points to help highlight which ones we're looking at as we're going through this. So if our input value is -2, where is that on my x-axis? So that's all the way down over here. Now if I go up to my graph, what point is that at? Let's write it here. And that tells me I'm going to have an output value of, let's see, 1, 2, 3, 4, 5. So I'm going to have an output value of 5 here. Now what about 0? 0 is an input value here. I'm going up to my graph, and I've got my next point here. Looks like it's at 1, 2, 3, 4. Fill that in. Let's make that a little better for her. There we go. Now what about 2? I'm going over here. Here's 2. Going up to there. And that gives me an output value of, looks like it's going to be 3. And then last but not least, I'm going over to 4. 1, 2, 3, 4. And I'm going up. And I have my last point here at 2. So in this instance, we have not been given an explicit equation. We don't necessarily know what the equation of this graph looks like. We might be able to figure it out, but it's not been given to us. That doesn't necessarily mean that we can't actually solve for output values. We just have them presented to us in a different way than what we're used to seeing. So be prepared for that showing up on the homework or on tests or things like that. Now looking at the problems for number 4, it's telling us graph shows below shows a function that has an algebraic form of f of x equals mx plus b, so slope-intercept form. Use the graph to determine the requested output values. All right, well, f of 0. Well, 0 is an input value. We already solved for it up here, so we just bring the answer that we had there right down for us. So f of 0 is going to be 4. I don't know what it is with me in writing 4s today. There we go. That's a better 4. And then similarly, f of 2, well, what did we determine that to be? An input value of 2, output value of 3. All right, f of 2 is 3. We can just copy that down from our previous problem here. Now question 5 is where we get to do this same idea, but we're doing it with an even less visual part attached to it, meaning no graphs. We're told the table below defines a function that has an algebraic form f of x equals mx plus b. Okay, so slope-intercept form again. Use this table to determine the requested input and output values. F of 2. If the input value is 2, what is the output value? 2 is inside of parentheses, which means it has to be an input value. So I'm looking at my table. Here's the x's. Those are inside of parentheses, so these are my input values. Where is that? Okay, there's 2. What's the corresponding output value? 4. So I can just log that in right here for my answer. What about B? F of 4. 4 is again an input value. Come down to 4. Output value is 8. I wrote in C here. It's not listed in this set of problems, but I think it's worth taking a look at. We're told in C, f of x equals -2. Is -2 an input value or an output value? Well, it's not inside of parentheses, it's outside of the parentheses, which tells me that -2 is an output value. So instead of looking at my input value column, I'm looking at my output value column. Looks here like I'm asked to find what value of x would make an output value of -2. So I'm just doing the reverse of what I did with A and B. I find -2 in the output value column, and then I'm listing that the answer is x is -1 as my final answer for a corresponding input value. So we have just a couple ways here of seeing the input and the output values depicted to us and how we could go through and calculate them based on a table or based on a graph. Again, come back with all of these two. Have I been given an input value and I'm solving for an output value? Or have I been given an output value and need to solve for my input value? Make sure you're double checking that before you're just writing in your answers. Alrighty, third and final page. The first note that I want to make, if you are tracking along and you're saying, wait a minute, we went from number 5 to number 7, we skipped number 6. There isn't a number 6 in the document. It mistyped and glitched, and so yeah, number 7 is quote unquote number 6 here. So you weren't missing anything in that regard. Looking at number 7, we're told use the graph of the function f to find each of the following. Now, the big thing that I want us to take away from this particular problem, and when you see problems like this, is the fact that we are going to need to start making some reasonable estimates with these problems if we are not finding points that are directly at these points of intersection on the graph. So we're asked about f of -4, f of 0, and f of 2. So I'm going to go ahead and do each of those in a respective color here. I'm just going to connect and plot each of those on this graph. So f of -4 is going to be over here. F of 0 is right here. And f of 2 is right here. Now looking at these things, we've been given input values. We're finding the corresponding output values. This is not at a particularly nice point. I mean, it could be, I don't know, it looks like it's at -1, maybe 1.25, something around there. It's not obvious exactly where this thing is. So the best we can do is write in, you know what, it's approximately -1.25, and you know what, that's going to be close enough. Make this 2.5 a little bit better here. There we go. So it's a reasonably close estimate. Nothing wrong with that. How about at 0? This thing looks like it's, I don't know, maybe at the halfway point, maybe a little below it based on where I put the dot. So, you know what, let's approximate this thing probably like 0.5, or maybe you could put it as 1/2 if you wanted to write it as a fraction. I think that's reasonable given where this is. And our last point looks like it's at, I don't know, 1.3, 1.25, something around there. Looks like it's maybe a little bit more, over a quarter of the way there. But you know what? Again, this is just an estimate. It's hard to eyeball these things and know we have an exact, very specifically correct answer here. So do your best to estimate these things as best you can. At the same time, do not get super caught up in measuring out, okay, how many millimeters apart is this line from this line, and that means that if it's this many apart, it's got to be about halfway, or it's a quarter way, or if it's a 5/8. So the way don't worry about that. Don't get too bogged down in that level of detail, especially if you're in my class. I'm not going to give you something where I'm going to be that petty about the answer. Looking at number 8, we're asked to use the table, the function f of x, to find each of the following. So we have our table here. We have f of 1 and f of 6. Are we given input values here, or are we given output values? These are input values, so I'm looking at my input column to try and find the corresponding output values. So for our first one, we have f of 1. Where is that? It's going to be right here. So what's the corresponding output value? That's going to be -8. With our second one, I've been given an input value of 6. That's going to be right below that, it looks like. And that has an output value of 2. Now for our last two examples here, working with number 9 and 10, we are going to be jumping over to a different program and using a graphing calculator emulator to set these things up and write them out. So as necessary, I would write out this equation, these equations for yourself, and write out the table of points that we need to solve for, because we're going to jump on over to that other program, do everything in there, and then come back to this one. So, looking at our program here, we have been given for our very first function, f of x equals negative 2x plus 5. What we want to do in our graphing calculator, I'm just here at the home screen, we're going to go up to y equals, and I want to make sure everything in here is cleared out, so use the up and down arrows and the clear button to clear everything out at the very beginning. We don't want any extra equations in here. I'm then going to type in negative 2x plus 5. Subtle but very important note here. If you are going to enter in negative, not subtraction, but negative, you are going to use this negative button down here by the enter sign. Negative 2, the variable button is right here next to alpha, x plus 5. Calculator is very dumb. If you were to put in the subtraction sign here instead of negative, it will give you an error. So make sure you're checking that you're using the negative sign, not the subtraction sign. Now that we have this, if you want to look at the graph, you can. You don't really have to. If we were to look at it, it's going to be this graph button here. And hey, there it is. That looks kind of nice. However, we're asked to fill in a table. We want to see a table of points, and this isn't exactly giving us what we want there. So to get to a table, we're going to click on second and then graph. That has us do this, or has the calculator do the table option. Now we're noticing here we've got 0, then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we get to 10. We can keep scrolling up and down until we get to, there's 20 right there. And then we would have 30 right there. Keep scrolling down, and here we have 40. I think we need, 50 and 60. I'm looking at it on a different screen. Yeah, 50 is written in right there. And then 60 at the very end. So there I've just plugged everything into my graphing calculator. I went to the table option, and I can scroll up and down to find all of the input and corresponding output values that I need. I'm going to go ahead and scroll this back up to 0, right where it started. Now with our second example, I'm going to show us a slightly different way of listing all of these things for us. You're welcome to use what we did here in this example, or you're welcome to use this quote-unquote shortcut with our second example. Either one will work to view your data and view a table like we want to. Now I'm going back to my home screen. It's going to be the second mode, quit. It puts us right back to our home screen here. Problem 10 is telling us use the function f of x equals 2x plus 3. I'm going back into y equals in the top left corner. Y equals, I have an equation in here that I don't want. I can go ahead and clear this out. Make sure everything else is cleared out that we don't need as well. So we're good there. And now let's go ahead and enter in our equation. We are entering in 2x plus 3. Got that in there. Again, if you want to look at a graph, just click the graph button. Okay, so we should have values increasing, but I don't care about the graph. I'm trying to find values for that table of points that's been given to me. Now if I go back here, I can go to second table, and again it will display the table right where I left off for the x values. Now before you scroll up and down, I do want to show you another option that you can take to adjust it's called the steps or the intervals within the graphing calculator. Notice how the input values are all counting by 1. We can adjust that in our calculator to have it count by 2s, by 5s, by 10s, by hundreds, by thousands. whatever we would like it to. So we're going to go through how to do that, and I'll go through how to undo those settings as well, because a lot of people will change it once and then not go back, and then things go horribly, horribly wrong in later problems. So we're going to go up to and use this table set option here. So I'm going to click on second window. That's going to activate the table set. Where do I want my table to start? Well, I want to start at 0 because that's my first number. So I'm going to tap in 0 here. I'm going to scroll down and we see this little triangle TBL that says, what do you want the change in the table to be? So starting at 0, do you want it to count up by 1s, by 2s, by 5s, by 10s, whatever. So we want it to count by 10s here. So starting at 0, change by 10s. You can leave the independent and dependent as auto. It defaults to X and Y for those accordingly. So we can ignore these here, leave those settings as they are. Now let's go back to our table. So we're clicking second table, and there we go. We're starting at 0, 10, 20, 30, 40, 50, 60, everything we need right here, plus a little bit extra. So we can go back to that other page and we could write in all of our answers accordingly. And we'd be done with that problem. Now before we do that, before we close out of everything for our video here, I do want to show you how you can go back in and quote unquote reset these tables and these intervals so you don't have it as 10s for everything. We're going back into second table set, so I'm clicking second window. Table set, where do you want it to start? 0 is always a good starting place. What do you want your table to change by? If you want to go to the standard change by 1, we're scrolling down here, we're clicking the number 1, and then clicking enter. Goes to this other option, that's fine, but let's go check the table again, and we're counting by 1s. So that's how you can always go through and modify that change in table however you would like to. Some calculators allow you, as this one does, allow you to press the plus button and you can change the table from here. That's not all graphing calculators, so the second table set option is what I have found to be the most universal one that you can use. But otherwise, going back to our page, we would fill in the values that we have here, and then that is everything for our function notation material. A little bit of preview with our graphing calculator also.